In this question, we're going to go and look at the process of nuclear fission and the equations that are related to it. Right, remember that nuclear fission is the breaking up of larger atoms in smaller ones and they release energy at the same time. Unlike nuclear fusion, where you're going and you're physically fusing two smaller nuclei together. Right, that's often one thing that people get wrapped around the necks and you'll lose easy marks for. So the question says, nuclear fission and nuclear fusion are two processes that release energy. The following nuclear equation represents the fission of uranium-235. Right, it goes and it gives you the fact that it's been hit by a neutron. So that's one thing that you've got to go and talk about further on. It tells you that that causes the mass of the uranium to increase by 1. So that's going to be something worth noting. It shows you that it breaks down in barium and krypton. It gives you the mass number and 3 neutrons. So the fact that it's giving you the masses of them kind of implies that you might want to go and talk about them. So describe the process of nuclear fission. Use the information in the equation above. So some key things that you will want to go and note down is that the uranium nucleus absorbs a neutron. This increases the mass of the uranium nucleus by 1 to 236. That makes it unstable and causes it to break down into 2 smaller nuclei, so 1 beryllium or barium, 1 krypton, and in the process it gives out 3 neutrons and some energy. You could go in some cases and talk about those 3 neutrons going and hitting other uranium nuclei if the question was talking about a chain reaction or something like that, but in terms of this question it's not really necessary. So the question moves on to explain what happens in the process of nuclear fusion. Right, in nuclear fusion it's the opposite. So nuclear fusion is when 2 smaller nuclei are fused together to make a larger nuclei or a heavier nucleus. The conditions you need for this need it to be at high temperatures and high pressures. You might want to go and give an example of it. So tritium plus deuterium, you fuse those together and you'll make an atom of helium. Sometimes it will ask for a specific example, sometimes it won't. So next we move on to talking about fission reactors. It goes and it gives some information. If it's given this information, you'll have to use it in answering the question. It's not just there for the sake of it. So fission reactors are used in nuclear power stations. Engineers are developing fusion reactors for use in power stations. Fusion uses isotopes of hydrogen called deuterium and tritium. Deuterium is naturally occurring and can be obtained from seawater. Tritium can be produced from lithium. So lithium is also found in seawater. Right, table 1 shows the energy release from 1 kilogram of fusion fuel and 1 kilogram of fission fuel. So state 2 advantages of the fuel used for a fusion reaction compared with that of a fission reaction. Right, first thing you've got to note is that it's giving out a vast quantity more energy. So it's giving out a lot more energy. One of the other things is that the only waste that it's going to give out will be hydrogen, so that will be another advantage. The raw materials for fission, so deuterium and tritium, both come from seawater. We have lots of seawater, so we're unlikely to run out of it. And the fact that it's coming from seawater means that we can obtain the raw materials in large amounts. Unlike uranium that has to be mined up, there's relatively little of it. in comparison. So go back, have a go at answering this question, really focus on getting all of those key points down, really focus on how many marks each question's worth and work towards those numbers of marks.